As mentioned earlier, that the P-delta effect can be captured by performing the first order elastic analysis and then scaling up the result by certain moment magnification factor. However, one can also perform the rigorous P-delta analysis to capture the exact structural responses. Let's have a glimpse into this P-delta analysis. Now, before that, let's see what is exactly the second order analysis. So, in short, any structure whose displacement response is nonlinear to its corresponding load increments is categorized as a nonlinear or the second order effect. And the analysis to capture this kind of second order effect is known as the second order analysis. See the left hand side illustration. Here you can see the two different loads versus the displacement relationship. The perfectly straight one is the linear or the first order analysis, and another one which is having some curvature is following the nonlinear or the second order relationship. You can see that as the load P increases, it generates the additional moment on the displaced or the deformed structure, thus inducing the second order effect, giving rise to the additional displacement. One of the most commonly known second order effect is the P delta effect. Now, the P-delta analysis is a type of second-order analysis intended to capture the P-delta effect induced due to the large delta, like the drift of the member, and the small delta, which is the member's internal curvature thus formed. So, any structure like tall or the unbraced structure that experiences significant amount of gravity load in addition to the lateral force, the P-delta effect becomes more and more significant. Now, there are two different approaches to simulate the P-delta effect. The first one is the iterative P-delta analysis. In the iterative P-delta analysis, the iteration would be performed with some initial lateral disturbances, and at each iteration, a new additional displacement would be computed due to the second order effect till the convergence of the solution is achieved. And the second one is the stiffness modification method or the geometric stiffness method. In this method, the load-dependent geometric stiffness of the kg matrix is determined initially and the resultant stiffness is recalculated, which is the net value of the actual and the geometric stiffness. Now, with the resultant stiffness, the structure is resolved to capture the P delta effect. Now, instead, both the approaches can easily be simulated.